Hello everyone, welcome back to this video, and in this video we'll be learning a concept that 99% of people don't know about prefix sums. We'll be learning prefix sums for 2D matrices. So let's get started. So first let's learn what the problem setup is all about. So let's say we have a 2D matrix given to us, and there are some values in this 2D matrix. So you can imagine like a chessboard, and there is some value also written in each particular cell. Now, what I want to do, I want to calculate for any given rectangle or any given square, what is the total sum of all the cells in a particular square or a rectangle. Let's say I have a lot of different queries. One solution that easily comes to our mind is that go ahead and simply iterate over all of these particular boxes and then easily tell me like what is the total sum, right? So let's say if the total number of columns are m, total number of columns are n, for each particular query I will take order of n into m, right? And if let's say the number of queries is q, so the total time complexity is q into n into m, which is huge, right? This is like very, very huge. And this is something that we don't want to do. If we see the number of like the length of m into n, it can be like very, very huge, right? And what we want to do here is we must design an algorithm where some of this particular region works on order of 1 time complexity. This is order of n into m. We want to reduce it to order of 1. Concept that we'll use here is prefix sums. Now let's see how will prefix sum work in this case. It is actually very simple and really, really fun to learn as well. Let me try to delete this and also erase all of these elements. And let's complete our given matrix. So what we observe here is, let's say we are trying to build the prefix sum. And I say that this is 0, 0, and at any given I, j, I am storing what is the total sum of the elements which ends at I, j and starts at 0, 0. So if you look at this particular rectangle, the total sum will be stored in this particular cell, which is ij. Let's take a quick example of what we are trying to calculate here. So 1, 2, 3, 4. Let's say our initial square is this. Okay. Now this particular cell will contain the sum of all of these elements. So 1 plus 2 plus 3 plus 4 is 10, right? What will be there in this particular cell? It will be sum of this particular cells. It will be 4. For this particular cell, it will be 3. And for the first cell, it will just be 1 itself. This is what I mean when I say that at a particular I, j, we are storing what is the total sum of this rectangle starting from 0, 0, which is on the top left. So this is my top left. Now let's say I want to calculate what the sum, the value of I, j for this particular cell, which is here. Can I say that this will be a sum of, first of all, this particular, let's use different colors for good clarity. Can I say that this will be a sum of this particular rectangle? We already know the sum of this particular rectangle because we are iterating from the top left and we are and we are calculating everything. So let's say we know the sum of this particular rectangle on the top, which is ending at I minus 1 comma j, right? Let's color this pink. So we know that it will depend on this pink because we need to calculate the sum of this entire big I comma j rectangle, right? And this one is a small part of that particular rectangle. Now let's take a green color, and I also know the sum of this particular rectangle, which is my green color. Pay attention to this. This particular rectangle is colored as green, right? I also know the total sum of this one. Now you can see that I am actually adding this internal, let me use black, this internal rectangle twice, right? I am adding first in this big I minus j comma j, and I'm also adding at I comma j minus 1, right? Can I say that the total sum of I comma j is equal to, first I add this particular pink rectangle, which is I minus 1 comma j. I also add this particular rectangle I comma j minus 1, but because of this particular rectangle which is ending at I minus 1 comma j minus 1 just got added twice. So I need to subtract it. I subtract this I minus 1 comma j minus 1. And finally, we have taken care of all of these boxes, right? All of these boxes. But there is one small piece left, which is I comma j itself. So we finally add the matrix value, which was initially there, I comma j, to this particular sum. And that's how in order 1, we can calculate the sum of all the rectangles starting at 0 comma 0 and ending at I comma j, right? So this is the first part of the solution. We can easily build this, and using this we can calculate the total sum of any given square or any given rectangle. You can pause the video and think for yourself, how can you do this? And like one more good implementation detail is that we always, if there are m rows and let's say there are n rows and m columns, we will always initialize n plus 1 rows and m plus 1 columns. N plus 1 rows and m plus 1 columns. This makes it very easy to handle these handle a lot of edge cases. And like for example, if you are calculating for this 1 comma 1, you can always fall back to 0 comma 0, right? So this is a very good benefit of initializing n plus 1 rows and m plus 1 columns here. And I will show you in the implementation how will this help us. Okay. So now that we have calculated this particular thing, let's see what is the final formula for our any given rectangle, right? So let's say we want to calculate the total sum of this particular rectangle which is given here, here and here, right? Let's say this end is I comma j. We can actually use the notation which is given in the problem itself. So this is, okay, so lower right corner is R2 C2 and this is R1 C1, R1 comma C1, right? This is R1 C1. So now R2 C2 contains the sum of all of the elements which are there in this big rectangle, right? This is a big rectangle. So let's try to start building our sum. So we can first say that, okay, in my answer, first add the sum of R2 comma C2, but we have added a lot of different other elements as well, and we will try to subtract it. Okay, now I want to subtract all of these areas, right? This is not needed in our answer, like the orange area. And if you see, you know the sum of this orange area already. What is this? This is row 1 minus 1 comma column 2. This is column 2 and this is row 1 minus 1. So we need to subtract this particular area, right? I subtract R1 minus 1 comma C2, right? Now similarly, I also want to subtract this particular area, right? This particular area can also be subtracted using this big blue rectangle, right? And what is the coordinates for this? This is C1 minus 1. The column is one column behind this, and my row is R2. So R2 comma C1 minus 1. So we also subtract this. So we go ahead and also subtract minus S of R2 comma C1 minus 1. But if you see, you kind of subtracted this particular small rectangle twice, right? You can add it back once again to the subtracted value so that it becomes neutral. Like you subtracted this particular square twice, which is not even needed. And what is the coordinate for this? This is R1 minus 1 comma C1 minus 1. So you can just simply add the value of R1 minus 1 comma C1 minus 1. And just by using this pre-computation, right, using this prefix sum array, you were able to calculate the value of all the elements in this particular square in order of 1. And this is like pretty amazing. So let's go ahead and try to implement this solution. We will try to keep the formula on our right so that we can easily implement it. So first of all, we will calculate the number of rows and number of columns here. N is the number of rows, M is the number of columns, and the length of my matrix will give me my number of rows, and my length of matrix 0 will give me number of columns. Now let's initialize the prefix sum array. So we'll call it self.prefix. Right, so as I told you, we will do what implementation trick here. We will initialize n plus 1 rows and m plus 1 columns. So what we do here is we initialize m plus 1 rows for n plus 1 columns for n plus 1 rows. This is how you initialize a 2D matrix in Python. An m plus 1 sized array is initialized n plus 1 times. So that is essentially a 2D array. Now we will iterate over 1 comma n plus 1 all the rows, and we will iterate over all the columns, and we will implement the logic that we implemented here in the first part, right? So to calculate the total prefix value, so self of prefix I comma j, this is equal to, first of all, like the matrix value. So the matrix of I, because it's one indexed, I'll write I minus 1 plus j minus 1 plus prefix self dot prefix of I minus 1 comma j plus self dot prefix of I comma j minus 1 and we need to subtract self dot prefix of I minus 1 and j minus 1, right? So this is something that we do here. And finally, we need to calculate what is the sum. And this is the formula that we finally found out. So first we can make everything one indexed. So the row 1, column 1, row 2, column 2, everything is converted to one index. Row 1 plus 1, call 1 plus 1, row 2 plus 1, and call 2 plus 1, right? And what is our final answer? What we return is, it's my prefix self dot prefix value of R2C2, so which is row 2, column 2, minus self dot prefix of R1 minus 1, which is row 1 minus 1, comma, call 2, minus self prefix of row 2, comma, call 1 minus 1, and finally we add prefix of row 1 minus 1 and call 1 minus 1. Yeah. So yeah, I mean, you cannot directly come up with this formula. You need to take a pen, paper and pencil and try to visualize this yourself. So let's try to see if we wrote the correct code, if the syntax was correct, or did we make any mistakes. Okay, so I see that there is some kind of a syntax error. It's probably because of this new line. So I will bring everything to one single line here and then again try to run this. Because it's a very complicated code, generally it might take some time, and we can see that it is accepted, and we'll try to submit this one and see if it passes all the test cases. Okay, it does. Thank you for watching this video. Keep coding and see you in the next one.